This is Math 2, 11.2 notes. That's Math 2, Unit 11, Lesson 2. And the title is Solving by Completing the Square. Now, we did completing the square in our previous lesson. Today we're going to use that concept to solve equations, to solve quadratic equations. Okay. Solve. Number 1, x squared minus 10x plus 5 equals 0. Okay, the only difference between this one and the previous lesson is it was y, now it's 0, but there's still an equal sign, and we are still going to move that number over like we did in our previous lesson. We're going to subtract 5 from both sides. Now, when we subtract 5, the difference with today's lesson is 0 and 5 are like terms. We don't have to put y minus 5 like we did in our previous lesson. X squared minus 10x plus blank equals 0 minus 5 is negative 5, and remember, what I add to one side I must add to the other, so I put a plus blank there as well. Okay, now if you remember, what we did was we took that number, that middle number, negative 10, cut it in half and squared it. That was the rule for completing the square. Negative 10 cut in half is negative 5, squared is 25, and what I add to one side I must add to the other. And this, when I factor, is x minus 5 and x minus 5. That's what we do. Our next step is factor. Negative 5 plus 25 is positive 20. And then I write this as a quantity squared. Again, as I've said in a previous lesson, that's the whole reason we complete the square, is to be able to write it as a quantity squared. Okay, now how is this different from our lesson, our 11.1 lesson? On our 11.1 lesson, we subtracted the 20 to get it into vertex form. Now that I'm solving, I'm going to leave it like this. I'm not going to move the 20 over. And think of our last unit. We had stuff like this, and what did we do to solve? We square rooted both sides. Because remember, square roots and squares are inverse operations. They undo each other. And also remember, when you square root both sides, it's plus or minus. So plus or minus root 20. Now, before I move this 5 over, root 20, actually, I'll move the 5 over and then talk about the root 20. Let's move the 5 over. And we've talked about this before. 5 plus or minus root 20, they are not like terms, so we cannot go any further as far as combining like terms go. But 20 is breakable, like it breaks down into its prime factors. So I'm going to do that over here. 20 is 4 and 5. 5 is prime. 4 is 2 and 2. Oh, if I can circle that. So I have 2, 2, and a 5. The 2 comes out and the 5 stays in. Okay, so what does that give me? X equals 5 plus or minus. The 2 comes out, the root 5 stays in, and that there is your answer. Now, you cannot combine 5 plus 2 and 5 minus 2 because the 2 is attached to the 5, to the root 5. It's like saying something like this. 5 plus 2x, you cannot combine that to be 7 or 7x. It stays separate because they are not like terms. Same concept. This is as far as you can go. You cannot do 5 plus 2 and 5 minus 2 because the 2 is attached to the root 5. All right, let's try another one. Number 2. X squared plus 6x plus 15 equals 0. Now remember, we subtract the 15 because we want to complete the square, and that's what we do. We get rid of that number. X squared plus 6x plus blank equals 0 minus 15 is negative 15. And then plus blank, because what I add to one side I must add to the other. We take that middle number, 6, we cut it in half and square it, and we put it in our blank. 6 cut in half is 3, 3 squared is 9, and what I add to one side I must add to the other. And then I factor, those are the steps, equals negative 15 plus 9 is negative 6. This is x plus 3 and x plus 3 because half of 6 is 3, and 3 times 3 is 9. And I write this as x plus 3 quantity squared equals negative 6. And we square root both sides because square roots undo a squared, inverse operations. And don't forget you put plus or minus. X plus 3, oh no, can we take the square root of a negative? Not yet. We will take square roots of negatives in about a day or two, but for now we cannot. So we would say no real solution. And I say no real solution because there is an imaginary solution, which is what we're going to deal with in a few days, but for now, this is what we write, no real solution. What does a no real solution mean when we come to graphing? When it comes to graphing, there's going to be no x-intercepts. Okay, eventually these are going to be x-intercepts. This for us, no real solution, that means no x-intercepts, which is possible. We have had parabolas with no x-intercepts before. Okay, number 3, x squared plus 12x equals negative 20. Now, how is this one slightly different from numbers 1 and 2? This one, the negative 20's already been moved over. One less step. So it's already over x squared. Oh, and I don't know if I said x. I'm hoping I did and just forgot to write it. There should be an x there. X squared plus 12x plus blank equals negative 20 plus blank. Okay, so same thing as before, only difference is the negative 20 was already moved over. All right, so we take the 12, cut it in half, and square it and put that in the blank. 12 cut in half is 6, 6 squared is 36, and what I add to one side I must add to the other, and yes, these will always be plus signs because when you square a number, anything you cut in half and squared is always going to be positive. And it has to be positive because when we factor, we want the two signs to be the same. And the only way for them to be the same is if that last sign is positive. Okay, half of 12 is 6, and 6 times 6 is 36, so it does work. Negative 20 plus 36 is 16. X plus 6 quantity squared equals 16. And we're ready to solve. I do the inverse operation, which is a square root, undo. Don't forget your plus or minus. X plus 6 equals plus or minus. Square root of 16 is 4. It's a perfect squared this time. Up here it was not. 20 is not a perfect squared, but 16 is. Subtract the 6. X equals negative 6 plus or minus 4. And we talked about this on our previous test that because these are like terms, you cannot stop here. If you do, it's wrong. Negative 6 plus 4, negative 6 minus 4, and you get two solutions. Negative 6 plus 4 is negative 2, comma, negative 6 minus 4 is negative 10, no parentheses allowed unless you put them in two separate ordered pairs. So that's our solutions. X equals negative 2, and X equals negative 10. Two solutions here, 5 plus or minus 2 root 5. Two solutions here, negative 2, negative 10. No solution here because you can't take the square root of a negative number, not yet. All right, let's flip on over to the back. Number 4. Number 4, we're going to change things up just a little bit. Y equals x squared plus 8x plus 9. And we are going to write it in vertex form. We are going to find the vertex, find the x-intercepts, all stuff we've done before, and we're going to find the y-intercept. Okay, since it is in standard form, I'm going to find the y-intercept first. Remember we are going to graph, so leave room for a graph. Since it's in standard form, I'm going to find the y-intercept first, which we find by making x equal 0. So we get y equals 0 plus 9, which is 9. So my y-intercept is 0, 9. That's the easiest thing to find right away. How do I write it in vertex form? I'm going to have you guys do that part. Write it in vertex form. You're going to do on your own. You're going to subtract the 9, put plus blanks on each side, cut in half and square it. This is the one at the end. You're going to write it like this. Y equals blank squared. and then like plus a number or minus a number depending on what you move over at the end. You're going to write that here, find the vertex, and then we'll do the rest in class. And when we get into class, we will be graphing it as well. That is it for this lesson.